as 45.
Yeah.
It's not until 8 o'clock.
No, I thought the warning is supposed to be like from like now or noon or something until 6.
Yeah, that's what it says.
And then afterwards it's supposed to calm down.
This morning, I don't know. Weather.com disagrees. But
Really? That's why I looked at it on weather.com.
I just watched a video showing like wind blowing in different
So it
spots.
just sounds exhilarating.
It was.
Let's see. Let's look at the hourly. So we're under a wind advisory. Let's see if it's updated. All right, so winds at 3 p.m., winds 29 miles per hour, sustained, gusts up to 45, and 48-degree temperature. So 48 degrees with 29 mile per hour per winds, that should be a little, should be crisp. Especially going at 30 miles an hour on the boat. Oh, now I actually want to go boating even more. I'm totally going to do it. I'm going to take video. All right. Oh man, we should totally do this assignment in here. Shunting yard algorithm. Yeah, we wrote it last night in the grad class. That thing was a nightmare. All right, so let's see here. Which is ours? Oh, we're working in our cave crawler, right? Oh my gosh, so many files. Okay, so we have our driver here. So we started writing our cave parser that took in simple JSON. We called the parse method inside of this guy, right? Parse method. So what does cave parser do? He reads this guy in and builds up a single string called the JSON, right? And then when we call, so we wrote a bunch of helper functions in here. So then when we call parse, this guy starts the path of parsing. Okay, so what does it mean to parse? Well, we start our initial JSON object that we decided was going to be the top level of this guy, and then we start current pause off at the beginning of the string. So as long as we're not off the end of the string, what are we going to do? We're going to advance to the initial opening curly brace. Then we're going to go ahead and give ourselves our brand new object. Then we're going to call add variable, which should grab the very first variable, right? And then we're going to ask if there's a comma, then let's grab another variable. So if there exists a comma, go ahead and advance to that comma, then grab a variable. So the question we were trying to ask is how do we get an unlimited number of variables? Oh, well, so I guess this makes sense why I mean, this was the part you were supposed to finish. I don't think, does it error out before that? Code am we running here? So cave parser, this guy right here. Let's go to the, let's just do a system.out.println this dot the JSON. Make sure we're reading that in correctly. All right, it's stuck on my other class's program. Did you turn it off and turn it back again? All right. Are we supposed to have a quiz today? No. Oh, well, that ship has sailed anyways. I did start Eclipse, didn't I? All right, let's try running it this time. That's from our my binary tree thing from last night. But why? Okay, there we go. So here's our string, 1, 2, 3, okay? And we're gonna start walking through this guy. So very first thing we do is we look for, so let's walk our code here. So here's our parse function. Parse function says advance to this first character, create a new object, and then let's go ahead and add a variable. So we'll call this .get variable. So for right now, let's comment out this stuff right here. And just trace it up to this point. All right, so we went ahead and got to this point. Then we created our brand new blank object, and then we're going to call that object's add variable method. So what does add variable in Json Object do for us? Let's go in there. So here's the add variable. This guy's going to take in a JSON variable, and it's just going to set the two values there. So here's what we have inside of our JSON variable, or our JSON object rather. So we have a collection of variables as well as a number of variables, and we decided we'd have a maximum of 50 variables that we would allow. So where do we get our variable? We get our variable from this .get variable. So that takes us right here. So what does this .get variable say to do? Well, we have a local variable called pause. Very first thing we do is we try to read in the name. So we advance to the opening curly brace. We set the local pause equal to cur pause. Then we advance to the closing curly brace, and then we grab that substring. So let's go ahead and print out the name. Okay, so our initial thing, that should give us a 1, correct? So let's go ahead and run that. There's our 1. All right, so we got that part. So I'm going to steal this. Then we'll move to the colon. Then we'll go ahead and move to the beginning of our value here. So that's right here. Use the exact same technique. Get our value. Print out the value. Okay, so there's our value. Let's make sure we get a 1 out of that. And we do. There's our 1. Okay, so that's our value. Then we'll go ahead and build our JSON variable with that name and value pair. So Json Variable looks like this. So we have a name and a value, so we just build an object with our name and value. Okay? So that's what we have right here. We have a brand spanking new JSON variable called the variable built out of our name and value that we just proved we had. And then we're going to return that variable. Okay, so now we're sitting right here. Okay, so now we're back in here. That's the variable we just added. So now we add that variable to our object. That's inside of our JSON object, add variable. Takes a variable in as a parameter. As long as our current size, which starts off at a 0, is less than, in this case, 50, we'll go ahead and add the variable to bucket cur size and then increment cur size. And we're going to keep doing this as long as the length, as long as we don't run off the end of the string. Now, if I just do a break right here, which will get me out of that loop, we see our error goes away. All right? The reason we had the error is the logic we're missing here for reading in the rest of those variables that I said, what if we had to have an unlimited number of variables? We weren't walking that correctly, so we kept doing this over and over and over again, where every single time I just assumed the very next thing was a variable, where it may not have been. Does that make sense? So this is going to break until this is written properly. which was the homework assignment. Make sense? All right, so let's take it a step further. We're going to look for that comma. So this is the dude we're looking for. All right, so let's just print out in here system. Actually, have I shown you how to use the debugger yet? At the very least, you don't know what I'm talking about. All right, so at this point, the way I've always been debugging things is by doing little print statements like this, right? So I'll do system.out.println found comma, something like that. And let me make sure, yeah, I have that gone. So let's just prove we found a comma. Get rid of the break right now. Oh, sorry. So it found a comma. Make sense? All right, so that's how I would debug it right here, the way I've been teaching you. But what I'm going to do now is I'm going to teach you how to use a generic debugger. So I'm going to come over here. I'm going to right-click out in this column over here, and I'm going to say toggle breakpoint. And what this lets me do is if I run this program inside of what's called the debugger, it will stop at this point in the program, letting me step through it one line at a time, kind of showing me the current value of variables that are happening up there. Okay, and the way we launch the debugger is by clicking on the little bug here. See that guy? Okay, and that'll put us into debug mode. In fact, I think you could probably just go into debug mode by default and then hit play. Well, I don't know. I don't know if that's the case or not, but this is the way I always run it. So I go here, which flips me into debug mode. It'll run my program up to that line. Do I have a breakpoint here? Oh. All right, there we go. So I did get to this line right here. So if a comma exists, I got inside of this if statement, otherwise I wouldn't have been able to break here. That make sense? So now I have these controls up here. One of them is step into, one of them is step over, one of them is step out. And the other one is run to this line again. So resume just says run the program, continue to run the program, pick up where I left off, and run until I hit another breakpoint. And you can have multiple breakpoints inside of your program. So breakpoints are like pauses. Okay, so I've stopped right here. I'm going to go ahead and advance to the next comma. So let's step over that. That worked. Okay, then I'm going to try to add a variable. What variable? This .get variable. So let's go ahead and let's step into that. So this takes me into get variable. All right, so I'm going to go ahead and advance to the opening. So I just advance to the comma. Now I'm going to jump to right here. So that gets me this guy, right? So I'm going to step over, step over, step over, step over. Now up here, notice the name variable is 2. Isn't that pretty slick? How the debugger works? So I did just read in the 2, so that kind of replaced that whole idea of system.out.println name. Sometimes you'll still do printlns because sometimes it's just more convenient, but in this case we kind of want to see what's going down. All right, so now I'll advance to the colon, so we'll step over, advance to the opening, so now we should get to this guy right here. We just advanced to this place. Now I want to get to this guy right here. So step over, get pause, get this. We'll move past the value there, so notice value is now 2. We got the right dude. Okay, and so now we'll build our JSON variable out of that. Good. We'll return that variable. Takes us back here. We'll add that variable to our object. We'll go ahead and jump out of there. All right. Well, now we're back up here to the top. Well, cur pause. So notice you can expand these. So cur pause is currently a 23. Here's the JSON, so wherever line 23 is, we're probably right here. We've just consumed that closing guy. Okay, what's the very next thing it says to do? Advance to the curly brace. That's not what we want to do. We wanted to consume all of our variables first. That makes sense? All right, so the punchline is the code I gave you worked as long as you filled in your homework in there. So we don't want to jump back up here until we've consumed all of our variables. That make sense? All right, so let's go ahead and let's stop the program. jump back into Java mode here. So the question we had in here is, how do we get an unlimited number of variables? In our case, a maximum of 50, although in this case, we've only given ourselves 3. Okay, so if there's a comma, what do? We advance to it. So if comma exists, that's from our current place. If you remember correctly up here when I go to exists starts at our current position and continues on potentially to the end and returns true if we find a comma. Okay? Well, actually, exist takes any character, so it allows me to ask, does any character exist from the point I'm currently at in the string to the end? And if it gives me a true for a comma, that means we have another variable. Does that make sense? Okay. And actually, that's in our simple strings. Remember last time we were talking about how what we're writing right now isn't going to work for full-fledged awesome JSON. This is going to work for simplified mini JSON that we're writing here. Okay. So in our world, as long as there's another comma, there's another variable. Realistically, if we had a really complex looking JSON string, you potentially could have a comma way down over here, but be out of variables within the current JSON object. Does that make sense? All right, so in our world, asking, are there more commas is an accurate way of asking, are we out of variables? All right, but we're going to be evolving our world moving forward. So, how long, after I've read in the very first variable, after I've read in the very first variable, where we can probably assume if there's a JSON object, it must have at least one variable in it, right? Otherwise, it was a waste of time creating the JSON object. Whoever wrote it, they just put an opening and closing curly brace. Why? Doesn't make any sense. So there's probably at least one variable in it, so we can make that assumption. So after we read in the very first variable, as long as I see a comma, there's another variable. As long as I see a comma, there's another variable. So on and so forth. All right, so what do I want to do here? Right down here, I'm asking the question, if there's a comma, advance to it, and then go ahead and add the variable associated with it, right? Wouldn't that make more sense? While there's another comma, grab the variable. Is there another comma? Yes. Grab the variable. Is there another comma? Yes. Grab the variable. So when I'm done with this line right here, what does that mean? That means that I must be done with the JSON string. So I can, in all formality, I can go ahead and advance to the closing curly brace. Okay, and then run the program. And we get out of bounds this very last time when we try to go here. Okay, so after I've read in all the variables, I know I have a JSON object. So let's kind of trace this. So I'm going to add my breakpoint right here. We'll take this breakpoint out. So I know I'm getting to this, well, I suspect I'm getting to this point right here. That means I've already read in my variables, and we'll prove that. So let's go ahead and run this in the debugger. All right, so we are past that while loop. Now if I come in here and I look at the object, I should see I've added 3 things to it, 1, 2, and 3. So we'll expand object. Notice cur size is 3. Here's the variables. So we'll expand that. Bucket 0 is a JSON object. Here is that JSON object. Name is 1, value is 1. The second one, name is 2, value is 2. Here's the third one, name is 3, value is 3. All right, so it appears like I've appropriately filled up my JSON object, right? All right, so next thing I'm going to do is I'm going to advance to that closing curly brace. So let's hop that. Now we're up here to the top. Current pause is 38. here's our JSON string. So current pos should be at the end of this guy. But I've actually advanced just to the last legal bucket. I'm not past the last legal bucket. So if its length, punchline is I'm going right there. Does that make sense? So I will get into this loop one additional time because I didn't move past the last curly brace. I moved to the last curly brace. If I remember correctly, didn't we write a function to move past? Advance past next character, like that. Toggle that breakpoint off. Switch back into normal Java mode. Go ahead and run. There's our final object. If I go ahead and throw the breakpoint in there, we can run this in the debugger. Let's go ahead and run it to that endpoint here where we have return the object. Here's our object. 3 things are in there. We saw the 3 things. Parse was, his job was to ultimately return the JSON object. So that should do it, right? Okay. So probably infuriating for a couple of you, given that the entire solution was to change if to while and add this one line based on what was currently there. But follow the logic of why we had to do that, okay? So even though the final answer was just switch an if to a while, the question we were trying to answer here is how do we handle an unlimited number of variables, okay? We keep consuming variables as long as there's commas. That make sense? All right, so questions about that. We're parsing our simply JSON. Okay, so next step is being able to handle a little bit more complex JSON, right? So right now, our simple JSON handles things that look like this, where values are always strings, and we only have one level of object. Okay? So what if, let's go ahead and open up simple JSON. We'll just keep advancing our simple JSON to be a little bit less simple, but we'll keep calling it simple JSON. So let's go ahead and just give ourselves an object here at the end for our last one. So for 3, we're going to say A has a value of A, B has a value of B. So now we have 2 different types of values inside here. We have some values are strings, other values are objects, right? All right, so now we have to fix our, well, we need to upgrade our get JSON variable. Is that what we called it? Something along those lines at least. So this guy right here, get variable, he now needs to know, let's go ahead and run this again real quick and it'll break. He now needs to know when we read in this 3 and we go and jump to this guy right here, we are now interested in what kind of value I need to consume next. Am I getting a plain Jane string-based variable, or am I getting a object in our new, more advanced version of JSON? Make sense? How am I going to detect that? We talked last time that the variable names will always be strings. So does that mean we're good with this part of the code? That guy's doing his job. Every single time we have a variable value pair, the variable name will always be a string. So that code, perfectly legit, not going to break. This code right now, we know that all the time, names and values are separated by colons. That code works. No harm, no foul. Now we get to the problem. Problem is when we get the value, we are assuming that value will start with a double quote. Not so much anymore, because now we have a new kind of value that does not start with the double quote. So we need to be able to ask the question, what kind of value is coming next? That makes sense? Okay. We know that the next value the next thing we run into, the next non-space we run into, will tell us everything we need to know about the kind of value that exists. If the next thing I run into is a double quote, I'm consuming a string for a value. If the next thing I run into is a curly brace, an opening curly brace, I'm consuming a object as my value. That makes sense? All right, so we're going to write a little function. Private. Let's see. Let's call this guy, he'll return a string, let's call him get type. All right, and this guy's job is to advance from where we currently are to the next non-space and tell us what kind of value it is. In fact, let's call it get value type. And we'll put a little comment here. Returns the type of value we need to read in. Okay? So we don't want to modify cur pause. Cur pause is our constant placeholder of where we are inside of our string. So I need a local counter like we did before called pause that allows me to start off where we're currently at but not destroy cur pause. All right, so we'll say int pause is equal to this dot cur pause. That'll position us right at the beginning. So for instance, I just consumed this guy. Now I'm going to ask the question, what is the, I'm going to say get value type. So what this function should do is he should start walking from here, one step forward, and consume until he hits something that's not a space, which in this case is going to be right away. He's going to hit a double quote. And so he's going to hit a double quote. The type of value he's going to return is a string. That's the type of value that I'm expecting to consume. So if I hit a opening curly brace, the type of value I'm expecting to consume is a object. That makes sense? So all this guy's going to do is he's going to kind of peek ahead and kind of give me some information about what's coming up, what's coming next. All right? So we're going to say while while this dot the JSON at dot char at, it's a string, right? Pause. While that guy is not equal to a space. Sorry, while it's equal to a space. We're basically just going to burn, right? Move past it, move past it, move past it. We'll say pause plus plus. So this while loop is just going to advance pause past all the spaces until I'm sitting on something that's not a space. Now I want to ask the question. So I'm either sitting here, or I'm sitting here, or I'm sitting here. And I want to ask myself what kind of character that is. All right, so if this dot the JSON dot char at pause is equal to a double quote, let's return the string. Else, if it's equal to an opening curly brace, let's return the string object. And you could probably fast forward in your mind a little bit and say, if it's equal to a square bracket, we'll probably return array, but we won't do it yet. All right, we'll upgrade one step at a time. Now, one thing I want us to get out of this, and one of the reasons I like such as changing method names. Whatever, maybe it's happy now. One thing I want you to get out of this, and the reason I choose JSON as kind of a good way of introducing this stuff, is all hard programs are made up of a bunch of easy parts. Okay, I probably said that in the past before, but let's bring it back up. This feels like it's significantly more complex than anything we've written up to this point, doesn't it? But if we look at any little tiny piece of it, for instance, this guy right here, is there anything horrifically scary about that one little piece? Okay, so what we're effectively doing here is we're putting together a more complex entertainment center that we bought at Walmart. So if you go to Walmart and you buy one of the little ones that's just basically 2 legs and a tabletop, that's significantly easier to put together than the thing that has, you know, all the different shelves and things like that. We have to keep track of all these individual pieces, right? So that's why we're writing all these little functions. This is a little piece that if we use in the right way, it helps us solve a problem. Here's another little piece that if we use in the right way, helps us solve a problem. Okay, so we're introducing more of our custom-built tools into the solution. So even though the problem feels like it's more complex, our solution is made up of a whole bunch of little easy parts. Make some sense? All right, so supposed to be intimidating, but it's also supposed to be definitely supposed to be entertaining. We're all entertained, right? Like while you're doing your homework, there's no like throwing things and cussing and heavy drinking. Dry campus, so if heavy drinking, I don't want to know about it. Okay, so in any case, this guy is going to tell us what the value type is going to be. All right, so let's just throw an else in here so it makes it happy. Return, I don't know. All right, that's my catch-all. I know how to deal with double quotes. I need to know how to deal with opening curly braces. If it's something else, you've introduced alien JSON, and I'm going to say I don't know. Do with that what you will. Okay? Hot code. Hot code replace failed. All right, here's the issue. Something's still running. We usually get so is there a way to kill all of them? That should do it. All right, so now I've given myself a little helper function that will tell me, that will give me the type of value we're reading in next. And let's go ahead, since we're getting a lot of functions here, let's go ahead and put some comments before each of these guys. All right, so this is our constructor. Builds a JSON string given a file name. That's what that guy ultimately does. This guy returns true if C exists from curpos as a starting point. This guy moves curpos to the position of the next C in the JSON. This guy moves curpos one position past the position of the next C in the JSON. Get value does that. Get variable builds a name value pair and returns a JSON variable object, and that's the guy we're currently working on. And what does this guy do? This parses a JSON string. Let's say, let's put this parses the JSON string, and ultimately produces a single JSON object that might contain a whole bunch of other stuff, right? But at the top level, we have a single JSON object. All right, so far so good. So we have those guys. All right, so now inside of our get variable, when we read in our value, we need to now ask the question, what kind of value do we need to read? So let's say string type is equal to this dot get value type. So we just pulled that little tool out of the toolbox that detects the next type that we just wrote that function, right? All right, so now type will hold that. If type dot equals string, we're going to go ahead and do this stuff. Okay, but we're going to start modularizing this. Similarly, else if type dot equals object, we're going to do something else. So I'm going to steal this code right here. I'm going to cut it out of there. And we're going to build a couple of helper functions up here. So we're going to create a private string get string value. And this guy is going to advance past that opening double quote that we now know is there if we're calling this guy. Get our current position, advance past the next guy, get our value, and ultimately return the value. So this consumes and returns, well, let's just say gets. This gets the next value let's see, from, gets the next value as a string. So we would only call this guy if the next value is a string. Okay? So what will we say here? If it's a string, we'll go ahead and we're going to create our JSON variable here. Actually, let's just keep it all in one place. I'm going to take those two lines and we're going to just throw it in here for right now. If it's a string, go ahead and get the value of that string, and we're going to get the value by get string value. That's our function that knows how to get a value as a string. And then we're going to return that variable. Otherwise, we're sitting right here. That means we have an object to read in. So now we need to go and read it in an object. And what's an object look like? It's pretty much look like what our parse function already gets. So so right here inside parse, what does this guy do? Creates a brand new object. It zeroes out curpause, because that's where curpause always starts. And then what does he do? he starts walking from cur pause towards the end of our string, essentially, if we look at that code right there, is it fair to say that that code consumes a JSON object? It builds a JSON object? Is that what that does? Okay. So I'm just going to copy that for right now. And we're going to come up here. We're going to create a private JSON object, get object value. Okay, so this is the code that we already know consumes an object. Does the object stuff for us. All right, so we're going to start off at whatever cur pause is. Keep going until potentially we hit the end of our string. All right, but in this case, I will have to break out, and you'll see how that works here in a second. Now, I need to go ahead and give myself a JSON object here at the top. So JSON object, the object, is equal to a new JSON object. Okay, so that's that dude we built here. Here's our JSON object. So when we build a brand new JSON object, it initialize our array of variables, our JSON variables, equal to capable of holding 50, and then initializes the current size to this guy. Okay. So here's our JSON object we're going to fill. Then we'll start walking our string, potentially until the very end, but this might not be the last object in there. We'll handle that. So let's go ahead and advance to the opening string of that. Oh, and actually we give the value right here. Staying consistent. So here's our JSON object. This is where it actually gives a value when we first consume that opening curly brace. Then we add the first variable, so we're always assuming there's at least one variable inside of an object. Then we get any additional variables. Then we move past the closing curly brace here. And after we've moved past the closing curly brace there, we know that the object is done. Correct? I know that I have now finished building the current JSON object I was working on. From this perspective, if I'm sitting inside of this method, I have no idea if I was the big top level guy or I'm one of the little tiny guys somewhere in there. I just know I'm a JSON object and I have finished building myself. Make sense? That's what this tool does that we just built. So what do I do when I'm done building a JSON object inside of a function called getObjectValue that returns a JSON object? I return the object. That's what I do. Make sense? Build it, fill it, return it. That's what we expect getObjectValue to do for us. Now, we've advertised that getObjectValue will always return a JSON object. Or we've advertised that. Therefore, a while loop is what's called a pre-check loop, right? There's no guarantee we will ever get into the body of that while loop. We happen to know, because we are assuming perfect JSON is being sent into our program, that I would have only called this function if I had some stuff to read. Java doesn't know that. So Java's concerned that what if we don't get into this while loop? If we don't get into this while loop, then you may not actually return a value. So I can just go ahead and return null. So this guy appeases Java that this function always returns a value. We know this line should never be called. Make sense? We would not have called the getObjectValue function if we weren't doing something with it here. In fact, given that, what we can actually do is we can move this variable definition in here. And only even bring the object into existence in the event that we have read in a JSON object. Otherwise, our catch-all here is just to return null. You asked me for something, I couldn't find it, here's nothing in return. Okay? So that's what getObjectValue does. Oh, it's just yelling it. We haven't used it yet. That's fine. All right. So now when we're in getVariable, if the object that we need is a object, or the value we need is an object, we're going to call our getObjectValue function, which returns a JSON object. But I need a way to put that JSON object into a variable. So for right now, let's just say JSON object, the object is equal to this dot get object value. And that should go ahead and read in the object value for me. We need to get this into a JSON variable now. Okay, but we have a problem. That is, JSON variables only know how to hold string values. This guy. Not JSON objects. Make sense? Okay, this guy only knows how to hold string values right now. We're going to fix that. Okay, but before we do that, let's go down to our parse. And what does our parse do? Our parse starts off with curpos is equal to 0. But what is his job? His job is to ultimately get an object. Correct? Don't we already have a function now that returns for us a JSON object? So can't I just do this? Can't I move this line here and just say this dot get object value and get rid of the rest of that crap? Isn't that parse now? I turned getting an object value into a generic function. That way I can call it multiple times. That's the purpose of a method, right? Function, method, synonyms, right? It's a reusable chunk of code that we can write once and call over and over and over again. I'm calling it once here because I know that every single JSON string will contain at least one object. That's the top level dude in a JSON string. But as I'm parsing that string, I may run into values that are also of type object. And what do I do when I need to get a value that's the type object? Well, I get the object value. Wrote a function, I need it there, I need it here, so let's write it once, call it multiple times. Make sense? Purpose of methods in real life. Okay, that's why we wrote it once and we called it multiple times. So all parse is going to do is it's going to get the ball rolling with the current pos. Start off at the beginning of the string. Then we'll go ahead and this kicks the ball down the field. So we'll start by grabbing our object value. There may be more object values inside there. There may be even scarier stuff inside of there. But all I know is that eventually this guy right here will return for me an object value. And I expect it to be, out of all the object values in this JSON string, it's going to be the scariest one. Because it'll be the one that has the most stuff in it, because he literally is going to contain the entire contents of our JSON string, all packaged up nicely in its string value pairs, or the string pairs, and then some objects, and later on some arrays. All of it's going to be stuffed into this nice little package. Make sense? All right. Now, next thing is, we have these things called JSON variables. Now, our issue right now is that a JSON variable comes in a couple of flavors. We have JSON variables who have a name that's a string and a value that's a string. We have a JSON variable that has a name that's a string and has a value that's an object. And then fast forwarding, we're going to have a JSON variable that has a name that's a string and has a value that'll be an array. Right? Those are going to be our three different kinds. So we need to learn about something new in order to do this. So we're going to talk about, let's open up Keynote here real quick. Talk about something called inheritance. Okay, so sometimes having a single object is not descriptive enough. We need to be able to create top-level objects that partially define something and then create more evolved, I just like using that word because Dr. Locklear hates it, then create more evolved objects that further define or give shape to what we need. So we've already experienced this in action, even though we didn't really think about it. So if we kind of draw that picture, in Java, we have this top level thing here called an object that exists. We didn't write it. All right? From this guy comes all of the other objects that we've been introduced to. So one of those guys is the string class. Okay, we use strings pretty often. Another one of those guys is the random class. Okay, another one of those guys is the Json Variable class. Change the color of this guy. Oh, perfect. Obviously, I wanted you to adjust the text. All right, so I made this guy orange because we actually wrote him. In fact, here, let's make him more readable. And we wrote this guy. These came with Java. We had no control over them. They were handed to us. Part of the starter kit. All right. But now, as we're writing more complex programs, we needed the ability to write our own objects. And we decided, for the sake of argument, that one of the objects we needed to write was something called a JSON variable. And at this point, JSON variables have always been used to hold name-value pairs. Okay? And this is just kind of a scary name for something very simple, right? Our JSON variable object is what? He's an object that holds two strings, a name and a value. That's it. That's his entire reason for existence, is to hold two pieces of information. Okay, so we can't do very much. All right, but it looks a little scarier on paper, so it makes us feel smart. All right, so we have our JSON variable there that we wrote. But now we have the need to have multiple types of JSON variables. Okay, because now we've expanded our definition of what JSON is. So really what we need is a JSON, a normal JSON variable, and then we need something called a JSON Object variable. Make sense? So maybe a normal JSON variable holds a string, but a JSON Object variable holds something a little bit more. All right. Now, wouldn't we say maybe that to be consistent, we might then also, instead of having a JSON variable hold a string, that we actually have a JSON string variable holds the string. Does that make sense? So we're going to have two new classes here, one called the Json Object Variable, one called a Json String Variable. And these guys are going to actually have a common parent. So we're going to convert our Json variable to no longer be a class that we intend to create on that we ever intend to instantiate. So we're going to change this guy's text to red. Red means stop. All right. So what we're introducing here is this idea of an abstract class. So we have two separate things we're introducing here. We're introducing inheritance, and then we're introducing an abstract class. So we'll come in and fill in the blank for the abstract class here in a second. But let's go ahead and build our inheritance model first. So we'll go back into our code. Here's our Json variable. Guy looks like this. Now, what I'm going to do is I'm going to take the value out of that guy. Okay? We're also going to take the value out of here, and we're going to take the value out of here. So now a JSON variable is just the stuff that it has in common with all things that are JSON variables. That is, every single JSON variable, whether its value is a string or its value is an object in our current world, will always have a name that's a string. This is the commonality between all JSON variables, is what I have defined in here. That make sense? So now I'm going to create another class. And this guy is going to be called a JSON string variable. Okay? Is that what I called it over here in my picture? JSON string variable? Yep, JSON string variable. So we'll go ahead and finish that. And this guy's going to look like this. And we're going to say that JSON string variables have a private string value, and it has a public JSON string variable constructor. And this guy is going to take in a string value as a parameter, as well as a string name. Now, before I go any farther, we have to connect this guy to his parent, which is JSON variable, because we want JSON string variable to be a more specialized version of a JSON variable. And we do that using the extends keyword. All right, so now what we're doing is we're creating a class called JSON string variable. We're saying this guy adds functionality. He extends an existing class called JSON variable. And what does JSON variable give us? It gives us just a name and a way of constructing it. So now inside the constructor here, we could, right off the bat, we're going to try to say this dot name, and we don't get access to it. Okay, why is that? Name is defined as private. And what does it mean for a variable to be private? It means it's only accessible where? Where is this variable right here accessible? Where is its scope? Only inside of the class named JSON variable. Only in there. Okay? So, if I want to access it in here, we'll ask the trivial question. I would hope that we have some participation. Is this class named JSON variable? No. Different word. Right? Okay, that doesn't spell JSON variable. There's extra crap in there. Okay, so this is not that class. So if I need to have access to the name inside of that class, I have to loosen the reins a little bit. Okay, I'm going to make this guy protected. Okay, protected actually says several things, but effectively from our perspective, protected says this guy is accessible inside of this class and children of this class. That make sense? So by making it protected, I expose it to his children. So now I have access to this dot name if I want. So I can say this dot name is equal to name, and I can say this dot value is equal to value, and everybody's happy. Okay? Now, the issue here is that I already have a parent up here, my JSON variable, and this parent has a constructor that knows how to set the name. So why am I reinventing the wheel? Why am I doing this inside of JSON string variable when I could just call upon this guy to do it? Now, when it's only one line of code, you might say, okay, well, it's kind of tie goes to the runner or something like that. But we can certainly imagine that in some situations, this might be fairly complex. Maybe there's 50 or 60 lines of code in there. So rather than duplicate those lines of code inside of JSON string variable, why don't we just call upon our parent and have him do the work that he already knows how to do? So super is how we refer to our parent. So I'm calling my super's constructor. So this is a special syntax for calling upon my parent's constructor. And my parent's constructor here takes in a single string. Okay? So I'm going to go ahead and let my parent pre-construct me. And then I'll add my own little flair. That's what's happening there. Does that make sense? If you choose to use your parent's constructor, it has to happen at the beginning of your constructor. You can have comments before this guy, but I could not flip-flop these two lines. They have to be in that order. If I intend to leverage my parent to pre-build, pre-initialize some of my stuff, I have to ask the parent to do that first. Then I can modify myself. Okay? If I don't intend to use my parent's constructor, then you should not write a constructor inside the parent. We should dump this guy and just have parent exist as this. Make sense? All right. So there's our JSON string variable. We'll just leave it like that for right now. And I'm going to create another new class. We're going to call this guy a Json Object variable. And you can actually set your super class here, but I hardly ever do that. I usually just do the extends out someplace else. So by default, every object has a super class of the generic object, like our picture we drew a few minutes ago. That's this picture. Every object we ever create has a common parent, which is object. This guy has a parent, this guy, who has a parent, this guy. So this guy's grandparent is object. Make sense? This is the hierarchy. All right, so we come back in here. So we're going to say JSON object variable extends JSON variable. So he's also a JSON variable. And this guy has a private JSON object value. Okay? Has a value just like our JSON string value, but he's got a little bit different kind of value. Instead of being a string, it's a JSON object. So we'll write our constructor public JSON object variable. This guy will take in a string name and a JSON object value. We'll call upon our constructor, our parent's constructor, to set the name, and then we'll say this dot value is equal to the value that was passed in. Make sense? All right, so JSON object variables and JSON string variables, very, very, very similar to each other. They both share a common ancestor, that is a JSON variable. And all JSON variables say is that all JSON variables have names. But some JSON variables have string values. Some JSON variables have object values, rather. Okay? It is accurate to say that a JSON string variable is a JSON variable. It is accurate to say that a JSON object variable is a JSON variable. So, for example, if I had an array of JSON variables, I can stick both JSON object variables and JSON string variables into that array. So if I go to Target and I buy a container capable of holding shoes, I can put Nikes and Reeboks into that container. That makes sense? They're both shoes. They're special brands of shoes, but they're both shoes. They still make Reebok. Is Reebok still a thing? Doesn't seem popular anymore, is it? It used to be pretty popular. It used to be kind of like neck and neck with Nike. Is that not it anymore? Huh, that's weird. They had the pump, the Reebok pumps. Remember those? I had when I played tennis, I had the Michael Chang, the pump with the little tennis ball on it. You always had to pump up before you hit your serve because that would make you better. All right. Yeah, I was actually wearing my Reebok pumps when I broke my back. It was awesome. I've told you that story in here, right? Yeah, that was awesome. I should find the video sometime. That would be a good one to watch. Okay, so in any case, we've now created a hierarchy. So we've inherited from JSON variable two new objects, JSON object variable and JSON string variable. Now let me ask you this. Would it ever make sense for us to have a generic JSON variable? Or do JSON variables not completely stand on their own? Are they just kind of, almost like templates for our more specific types of variables? Could we ever create a JSON variable as just having a name going to be useful to us? Not really. Okay, so that's where the abstract keyword comes in. So an abstract class is a class that is built specifically to support inheritance. We can't create an instance of an abstract class. It is illegal to create an instance of an abstract class, which is okay for us in this case because we just said that it would never make sense for us to create an instance of our, for example, JSON variable class. It exists solely to support its children. Does that make sense? Now, we don't have to make that class abstract, but if we wanted to self-police ourselves, and anybody who in the future might use our code, use our objects, the idea is that we're building the solution with the idea that JSON variables do not make sense to exist on their own. They need the more specifics. Okay? So therefore, we're going to go into our code here. We'll go into JSON variable, and we're going to actually make this guy an abstract class. All this does is put a little padlock on him. It says, you are no longer allowed to create an instance of JSON variable directly. He exists solely to support inheritance. Make sense? That's all making a class abstract means. Okay. So, there's our JSON variable. Now we have our JSON string value, and we have our JSON object value. So now we have two different ways of creating JSON variables. So I can go back into my parser. Right here, notice it's screaming at me now I'm not allowed to create a JSON variable. So instead I'm going to create a JSON string variable. That makes sense? And I can store them inside of a container built for holding a variable, a normal JSON variable if I want, because a string variable is a JSON variable. All right, and what does this guy return? He returns a JSON variable. So anything that is a JSON variable can legally be returned by this guy. Okay, so it doesn't really matter in this particular case whether I store them inside of a JSON string variable or a JSON variable. At the end of the day, we're going to be shoving him into an array inside of JSON object. capable of holding generic JSON variables. So he's going to go into that array as a JSON string variable or a JSON object variable, but then I'm going to have to figure out when I pull them out of that array how to deal with them. That makes sense? Okay. And then very last thing here, just to kind of give us a good stopping point, is if we're dealing with our JSON object, we'll go ahead and we're going to get our JSON object. And then we're going to say a JSON object variable. Their variable is equal to a new JSON object variable, passing it the name and passing it the object that we just read in. And then I can return the variable. Make sense? So this function right here is called getVariable, and he returns a JSON variable. As I have it written right now, he either returns a string variable or he returns an object variable. And just to get Java to stop complaining, we'll return null right here. We know it's going to return one of those, so we'll leave it at that. Sound good? All right, so I would review this video over the weekend. You'll have a homework assignment on Tuesday, so make sure you understand everything we did here. And we'll kind of flesh this out a little bit more on Tuesday. Have a good weekend.